mass defect. In case of nucleus, see, there may be n number of nucleons within the nucleus. Suppose if you try to find out the mass of all the nucleons put together, that should give you the total mass of the entire nucleus. But there is a difference here. If the mass of the nucleus is measured independently using a mass spectrograph, you will get some value. And if you calculate masses of, you take the sum of masses of individual nucleons, that will give you another mass. They are different, and the difference is known as mass defect. You can say that mass defect is the difference in the masses of the nucleus, theoretical mass and actual mass. That difference is known as mass defect. Let us say, for the sake of argument, you are having an element X with Z number of protons and A total number of nucleons. Obviously, number of protons is given by Z and the number of neutrons is nothing but A minus Z. Right? Now, let us consider that mass of each proton is mp and mass of each neutron is mn. So, if you want to calculate the mass of the nucleus X, then what we will do, there are Z number of protons, each of mass mp, therefore total mass of protons will be Z into mp. Next, there are n number of neutrons with mass, each of mass mn. So, the total mass of all the neutrons will be n into mn. So, if I take the sum of these two, I will get the total mass of the entire nucleus. This is one quantity. But if you measure the mass of the nucleus independently using mass spectrograph, we will get a different value m. Actually, experiment shows that the actual mass of the nucleus independently measured using mass spectroscopy is less than the theoretical mass. This difference between these two is known as mass defect, generally represented by delta m. So, mass defect is the difference in the masses of the nucleus, theoretical mass and practical mass or actual mass is known as mass defect. In order to give a clear picture of this one, we will take one example with which we can calculate the mass defect of a particular nucleus. Now, we will see the mass defect in case of a particular nucleus. Let us take oxygen nucleus with 8 protons and 8 neutrons. Its mass number is 16. Therefore, number of neutrons will be 16 minus 8 will be 8. Now, mass of each neutron is equal to 1.00866 atomic mass units, AMU, generally written with a this thing U, AMU. Next, mass of each proton is 1.00727 U, atomic mass units. So, if you want to calculate the total mass of all the nucleons within the nucleus, what we need to do is, there are 8 number of neutrons, each of mass 1.00866. That will give you total mass of all the neutrons. Then there are 8 protons, each of mass 1.00727. That will give you total mass of all protons. Take the sum, that will give you the total mass of the nucleus, oxygen nucleus. That will give you, actually, if you add these two, it will be 16.12744. That is the value of theoretical value of oxygen nucleus. But experiments like using mass spectroscopy, you can calculate, you can determine the value of mass of oxygen nucleus. That will be, let us say, is represented by mass of oxygen nucleus using spectroscopy experiments. That will give you about 15.99493. you can clearly see that the actual mass of the oxygen nucleus 15.99493 is less than the theoretically calculated value 16.12744 U. So the difference in these two masses is known as mass defect. That is, if you take the difference between these two values, delta M will be 16.12744 minus 15.99493. That will give you 0.13691. That's mass defect in case of oxygen nucleus. So this is what mass defect means. The mass of the total sum of all the masses of individual nucleons put together and the mass of the nucleus determined using experiments, the difference between them is known as mass defect. In case of oxygen nucleus, this is equal to 0.13691 AMU.